Welcome to this first meeting of 2024 in the Microsoft Fabric User Group of Denmark. My name is Brian. I'm your host for today, and today we have Pawel on board as the speaker from Microsoft. Pawel, you can introduce yourself in a few minutes. As usual, I have a upcoming events slide for you. On February 1st, we have our next meeting with Sally Dabber. She will talk about the data analytics platform of Microsoft Fabric, a general discussion of the platform. And then we have Armando on board, who will show you around the Spark Compute inside Fabric. And a week after that, we will have Kevin Chant, also an MVP, to talk about Azure DevOps around Fabric. And then we have the big events in the United Kingdom, SQL Bits 2024, and this year's theme is aviation. So you'll see that in a few seconds. Enough about me. Now over to Pawel. You can introduce yourself in a few seconds, and I'll hand the screen over to you.
Thanks, Brian. And thanks for inviting me to this great user group. Let me know if you see the screen, please.
The screen is shown now. Yeah, thanks.
All right. So welcome to this session, Microsoft Fabric for SQL developers. After you presented the schedule for next meetings, I think this session might not be the best as a first session for Fabric, but hey, I don't think you will you will get distracted by this session when it comes to the next session on general overview of the whole platform, because I will focus only on those things that are related to SQL developers. So this session is dedicated to two kinds of people. I am not sure which one you might be. The first type of the audience, SQL developers. If you love SQL and you wish to work with SQL in Fabric, this session is for you. And the second type of person, if you for some reason don't know SQL, you will find out why SQL might be useful in Fabric and in which parts of the platform this language is useful for development. So with that, let me jump into this topic. Before let me just introduce myself briefly. So my name is Pawel Portasinsky. I work at Microsoft, specifically on the Microsoft Fabric customer advisory team. I'm fortunate enough to work on a team that works with some of the biggest customers using Power BI, Azure Synapse, Microsoft Fabric, and other platforms for data and AI. I spent over 20 years working as a data professional. Started as a SQL developer and moved towards BI and some other stuff related to analytics. I used to be Microsoft's most valuable professional on SQL Server and data platform historically. So I know the value of the community well, and of course, I used to be somehow related to community in 2007, so quite a long time ago. I started the user group in Poland, originally called Polish SQL Server User Group. Right now it is called Data Community Poland, so it still exists, and it runs an annual conference called SQL Day in May in Wrocław. So feel free to jump into sqlday.pl to check out this event as well. I still support this event, so it's a great fun for me. And most of all, in the context of this session, I love SQL. I used to think in SQL. Right now, maybe I have some mix of languages, SQL, DAX, and other stuff. But still, SQL is a preference of my own. So whenever I can solve problems with SQL, I pick SQL. I pick SQL as my first choice programming language for data. Oh, sorry. One more thing. I don't have any blogs, but you can jump into my LinkedIn network just by simply scanning the QR code on the screen. So feel free to connect with me on LinkedIn. Until this month, I used to run my newsletter on what's new in Fabric, Power BI, and other stuff on Microsoft Data Platform. Due to some turbulences in my free time, I just had to stop working on this newsletter, but I hope you will find some historical issues of this newsletter useful for you. So feel free to also jump and see this newsletter on LinkedIn. So with that, let me share my agenda for today. It is quite straightforward. So I will start with answering question why, because typically it's good to present some purpose why SQL is so important. And then I will jump into just a single slide that will present you with options you have to work with SQL in Microsoft Fabric. And then I will just expand them to demos. So this session is demo intense. There'll be lots of code, as you may expect, SQL code. But don't worry. First of all, this code will not be super sophisticated. It will be both applicable to well skilled SQL developers, as well as people who really have just the basics of SQL. And also I will share the link where you will be able to find all the demos available for you. I will let you know where you can download the data I'll be using for demos as well. So hopefully you will be able to reproduce the demos yourself. And finally, I will present you with some links and next steps for you to learn. Again, you don't have to make screenshots of my slides, because the slides will be shared as well. So just enjoy watching and asking questions. Also keep in mind that through this journey today, I will have my virtual assistant called T-SQL Rex. And why I selected Dinosaur as my assistant? Because he has the same characteristics as SQL. He's old and he's powerful. So with that, let me jump into answering the first question, why we should care about SQL. Yeah, you cannot be both Microsoft MVP and Microsoft employee. Thank you. So I took, for the purpose of this question, I took some research from IEEE. If you don't know, IEEE is a research organization, actually scientists organization. And one of their initiatives is annual ranking of programming languages, which programming languages are the most popular in the world. And it appears that SQL is still, even taking into account that it exists for ages, I would say 50 years or so, it's still in top 10 languages when it comes to programming. Also, please note that out of the 10 languages presented on the screen, SQL and Python are the only languages that typically serve as languages for data processing and analytics. Okay, so the observation here, SQL is has still a strong position on the market, is used in many cases, but Python is number one. This is the first observation. Okay, keep in mind. Now, second, if you switch to the second part of this research and look at job descriptions, SQL is positioned as number one. So the outcome, SQL appears in most job descriptions on the market. However, keep in mind that typically SQL is not the only language listed in job descriptions, but it appears to be one of the many languages that is required for a specific job. To give you an example, if you want to be a good data engineer, typically you should have a combination of SQL and Python. And please note that Python again is very high in this ranking. It's number 2. And the third one is about trending. So which languages are constantly growing in terms of usage, which are more and more popular, for which languages you will notice more and more use cases. And still, SQL is very popular, but you see again Python as number 1. And my outcome for you from this is because Python is more general programming language than SQL, and right now it also has some use cases for programming the generative AI. We are in the era of generative AI. Even during this call, we exchange thoughts on how we use ChatGPT. So I hope you started working on your prompting skills, because this is one of the requirements for the future world of programming, or even today's world of programming. Without this, you probably will you will be left behind in terms of productivity. Okay, so to wrap it up, you should care about SQL because SQL is still top trending programming language. When it comes to data processing, it is among the top 2 languages that we have on the market. Python is the language that you should consider to learn. This is the learning from IEEE's research. So let's jump to Microsoft Fabric, because this session is not just about SQL, but SQL in Fabric. I don't want to cover things that will be shown during the next session at this user group. So just briefly, what is Microsoft Fabric? It is the end-to-end platform for analytics, but don't get wrong the concept of Fabric, because Fabric is very general name. So over time, you may see that this platform will grow and it will cover more things than just analytics. But right now, it covers analytics. The purpose of Fabric is to give you a single platform that will allow you to run projects for analytics end to end, starting from data ingestion and integration, transformation, through some concepts of storing data and serving data, like data warehouses and lakehouses, through some specific scenarios like real-time analytics and data science, ending up at serving layers like you know from Power BI. So Power BI is a part of Fabric right now. And then also it goes beyond just analytics, but because it provides you an experience called Data Activator, which is responsible for turning insights into actions, which means that whenever I see some values in my Power BI report, I can start some actions. It's not just about Power Report, but to simplify, you may start actions based on the values in Power BI. Those 7 boxes here are called experiences. Some people call them workloads. In documentation, you will see this keyword experience, so I will keep consistent, and those are experiences. The number of experiences may grow over time, so we have 7 experiences right now, but in the future, you may see more. The most important thing, all those experiences are one product. It is not a bundle of different products, because some people may have impression that Microsoft took Data Factory from Azure, Synapse Analytics from Azure, and Power BI, bundled it together, and just renamed it as Microsoft Fabric. It is not true, because all you see here is based on the common single architecture. It was actually taken from Power BI. And in terms of Data Factory and Synapse experiences, it is all brand new experience, new engines, redeveloped things, with all the new all the I would say bunch of new capabilities available. So you will see that in a moment. Everything here, all the experiences, have the same baseline. So you will see lots of things unified security, unified governance, and most of all, in terms of today's session, unified storage baseline, which is called OneLake. It is a single data lake that serves for the purpose of Fabric's tenant. So if I have my Fabric tenant for an organization, imagine that everything from warehouse, lakehouse, Power BI, semantic models, even real-time analytics databases will store data in OneLake, in a single data lake for my organization. And that makes lots of capabilities open for SQL developers, and I will try to show you that later on. And most of all, this product comes as a software as a service product, which means you don't have to to provision any clusters, any virtual machines. It just runs. Okay. So with that, let me jump into covering where you can use SQL in Fabric. And then I will just show you demos with lots of use cases, lots of scenarios where SQL is applicable in Fabric. So let's start with concepts of data items. Data items are things in Fabric that store data. Typically, you will see 4 data items, at least for analytics. Warehouse and lakehouse are the most natural data items for SQL developers. And why? Because for warehouse, Transact SQL, known from SQL Server, is actually the language that you use to operate on data. You create tables, you create other objects like views, procedures. You can load the data into tables using T-SQL. You can query data, you can update data, and delete data, pretty much everything. The other item is Lakehouse. Lakehouse is a bit different because it puts database structures, tables, over files. So you will see that Lakehouse has actually the layer of files and above that the layer of tables. So how you work with Lakehouse? You have 2 choices. First of all, the very native way to work with a Lakehouse is to use notebooks. So you will work with notebooks just as you know notebooks from open source environments or Azure Databricks, for example. You will be operating with lots of languages, different languages, but Spark SQL is one of them. So just to let you know, in notebooks, you can use Spark SQL, which is another dialect of SQL. It's not Transact SQL, T-SQL, but another SQL language. And also, Lakehouse comes with something called SQL Analytics Endpoint. The experience of this endpoint is very much like a Lakehouse, but the difference is that you can access Lakehouse using Transact SQL with read-only access. So you only read data from tables. You don't write or update data in those tables using T-SQL. For update, inserts, deletes, you will use Spark SQL and notebook experience in Fabric. When it comes to warehouse, you just run T-SQL and you can use classic SQL developer tools, which means you can access warehouse and SQL Analytics endpoint for Lakehouse using SQL Server Management Studio, Visual Studio Code, or Azure Data Studio. Any of those are applicable. You can access using T-SQL. Even more, you can use those tools. Those that support notebooks, you can use those tools to open notebooks and go through this path using Spark SQL as well. Also, because of the nature of storage behind both those items, keep in mind all of the data stored in warehouse and lakehouse sits in one lake, so a single storage layer. You can use cross database queries between warehouses and lakehouses, or between two warehouses or 2 lakehouses sitting in the same Fabric workspace. So a single Fabric workspace is this boundary for cross database queries. If you want to use cross database queries, what I mean by cross database queries means that if I can query a table that sits in one data item and in the second data item at the same time and join this data together. So if you want to run cross database queries, having objects, data items stored in separate workspaces, you still can do it, but first you need to create shortcuts that will point to the 2 tables sitting in different workspaces. You can also specify shortcuts to data items sitting in the same workspaces. And shortcut is this very powerful mechanism that is used on top of one lake. So we benefit from the fact that every data stored in data items, warehouse, lakehouse, and other data items that I will show you in a second, they sit in the same storage. And I can just point, instead of copying data between those items, I can point to tables created already by somebody else in another data item and query this data as it was stored in my lakehouse or other object. Okay. Typically, you will create shortcuts in lakehouses. And the reason is because lakehouses offer you the most powerful options when it comes to creating shortcuts. 2 other data items that you may see in Fabric will be KQL database, Brian's favorite part of Fabric probably. So just to clarify, KQL database is a database for scenarios where you are not performing classical analytics, historical analytics like with lakehouses or warehouses, but rather you focus on data that is appendable only. So logs, telemetry data, data coming in semi-structured files like JSON. And you want to analyze this data in a quick, dirty, ad hoc manner. And with very powerful text indexing and quick searching. So this is a database which you may know from different products of Microsoft, specifically Azure Data Explorer and Azure Synapse Analytics ADX pools. So typically, you should operate over KQL database using KQL language, Kusto query language, but it is also possible to operate with T-SQL or SQL in general over KQL database. I will show you the option of querying this database using SQL, but then I will elaborate why you should also consider learning KQL as well. And finally, last but not least, keep in mind, Fabric born from the ground from Power BI. We are based on the Power BI's architecture, so Power BI's data items still exist in Fabric. You have what used to be called dataset, but now it is called semantic model, and it is another data item that may store. It is not by default, but it may store data in OneLake as Delta format. I will refer to Delta in a second. And then you can create shortcuts to semantic models in lakehouses and query the data in semantic models using the same methods that you normally run for lakehouses. Keep in mind that semantic models integration with OneLake is in preview, so you will not see right now, it's probably gonna change, you will not see the capability of using SQL Analytics Endpoint and T-SQL to query semantic models via shortcuts. You will be only able to use notebooks and Spark SQL right now, but in the future this may change. For KQL database, you have both options, so you can use both T-SQL and Spark. Okay, there's also a mechanism that allows you to access semantic models without creating a shortcut, and this is basically based on one of two options. One is the native connector to Power BI semantic models that you may add to your session in Spark, and that will allow you to access semantic models using Spark SQL. And the other option is semantic link, which is a very powerful library that allows you to access even metadata of semantic models, very useful for Power BI developers scenarios. So I will show you that in demos as well. So this is not it. This is not all. Actually, there's more. You can even use queries in SQL over data that sits in external storages. Specifically, right now you can access Data Lake Storage Generation 2. So classical Azure storage that you might be using already with Azure Synapse, Databricks, or other stuff. Dataverse that comes with Power Platform and data and the Dynamics 365. So if you store data in Dataverse, you can also use this data via shortcuts. You can also connect to Amazon S3 buckets right now in read-only mode. And also we are working on adding Google Cloud Storage to this set. So you can, as you can see, the broad range of external cloud storages may be accessible using shortcuts in lakehouses for SQL developers as well. And finally, we are working on something called mirroring. This was announced in November last year at Ignite. So you will see mirroring, which is real-time replication from databases like Azure SQL, Snowflake, and Cosmos DB, which means that you will be able to query data taken from those platforms in warehouses using T-SQL. Cool. So as you can see, lots of opportunities for SQL developers to work effectively with data in Fabric. I hope you will find this diagram readable. I worked on it quite a long time just to have a single slide on that. So the wrap up from my friend T-SQL Rex from this slide is this. If I was a SQL developer working and I was about to work with Fabric, I would consider several things to learn. First, you should establish some knowledge on working with OneLake shortcuts, how to create shortcuts, which shortcuts you can create to which data items and external storages. That is for sure one of the most powerful capabilities of Fabric. Spark SQL, this is another language to establish because this will allow you to effectively work with data structures over lakehouses. Pipelines and data flows, generation 2, those are two mechanisms that I will not cover today, but just for you to know, they exist in Fabric to make data ingestion, so loading data to your data items like warehouses and lakehouses easy. Finally, the concept of medallion architecture should be you should be familiar with this, because typically for large organizations especially, you will follow this pattern, and it can be built on top of several different data items. It doesn't have to be a set of lakehouses, but it can be a combination, a good mix of lakehouses and warehouse. Typically, if warehouse comes into the medallion architecture, it will sit in the gold layer for serving data to BI solutions and data science. So there are two more things to learn. I warned you this will be also about learning and expanding. So Gusto query language, if you plan to run some real-time or observational analytics scenarios and have your KQL databases, then KQL absolutely is your friend to learn. And semantically, if you are a Power BI developer willing to expand and have some not just SQL but also Python capabilities at hand to for example test your semantic models, that would be useful. All right, with that I will switch to demos and spend the rest of my session at demos, hopefully. So I'm in the Fabric workspace. If you look at Fabric is very similar to what you might know from Power BI. The difference is here at the bottom left corner of the screen. I have this little switch with Power BI icon in my case, but I can switch to between different experiences. So if I want to work as a data engineer, I can switch to data engineering, and then I have data items and objects, the items typical for data engineers like lakehouses and notebooks at my hand. Creating an object, a data item in Fabric is as simple as clicking on the style of selected data items like lakehouse and just providing a name. So nothing sophisticated, again, no provisioning, no compute power to spin up, no virtual machines. Because I have my data items ready and created, I will skip this step, but just for you to know, name is the only one thing you need to provide. Now, to have this experience, Fabric experience on your Power BI tenant, just a note, you will have to jump into the admin portal, and there are two options to activate. One is this one, users can create Fabric items. This will allow you to see Fabric experiences except so beyond Power BI. And the other one is here, users can try Microsoft Fabric paid features, which means that users will be able to start trial capacities for Fabric and test Fabric effectively, because you need to have some capacities to be able to host workspaces that will be used for Fabric items. Now, keep in mind, there is a limit of 10 trial capacities per tenant, so be mindful about running too many trials. Ideally, I would suggest every one of you should start just a new tenant for testing Fabric, just for your purpose, and avoid testing it in organizational tenant, except the situation when you are responsible for building Fabric competencies. Okay, but enough of this administration stuff, because we are about to run some SQL stuff. So I have a workspace, and just for you to know, before I jump into the code, I will give you the look and feel of data items that I will be working with. So I will be working with all 4 data items: warehouse, lakehouse, warehouse, KQL database, and semantic model. Let's start with a lakehouse. So this is a lakehouse with already some data in it, but note 2 things. First of all, lakehouse is divided into 2 sections. First is called files, and it is so-called unmanaged part of the lakehouse. So here you can upload pretty much everything. You can load your files for analytics like Excels, CSVs, Parquet files, whatever you have. You can load binary files like images, anything that comes to your mind that might be useful for analytics. You can put it here in subfolders. You can create a hierarchy of subfolders and just keep it here, just like in normal data lake. But then you have another layer called tables, which is so-called managed part of the lakehouse. And here, lakehouse keeps its tables. Tables can be stored in many formats, not only in Delta format, but in my case, all tables are stored in Delta format, and this is for a reason. Whenever you want to standardize and use tables across all the layers or the experiences in Fabric, you should stay and stick to the Delta format. Otherwise, you may be not able to see your tables in, for example, semantic models if you decide to store a table in Parquet format. So Delta Lake is your friend in Fabric. It is standardized on Delta when it comes to table storage, not just in Lakehouse. It is also true for warehouse, KQL database when you decide to store KQL tables in one lake, and semantic models when you decide to store semantic models in one lake. So lakehouses and warehouses store tables by default in Delta format in one lake. For KQL databases and semantic models, it is up to you whether the tables will be stored in one lake in Delta format. But Delta is the gold standard for format. And why Delta? Because it is open source, because you can use Delta with other platforms, Databricks to name one of them.
Pawel, there is a question in the chat, a rather a long one from Gupta Ashi. There's a 3-question set up here. So I think the first one is, how can they see the allocated storage in one lake? Yeah. And check its usage. I think we need to go into the Fabric capacity metrics thing.
Yeah. So Ashi, can we take those questions to the end of my session? So
I'll save them for later, and
let's save them because they will probably require me to jump to some sections of Fabric, and but
I'll save them.
Point taken. Thanks. Okay, so this is Lakehouse. Lakehouse has 2 views. This one is Lakehouse Explorer, and you can switch the views in the top right corner between Lakehouse and SQL Analytics endpoint. So let's switch to SQL Analytics endpoint. And this one is for running SQL queries, actually T-SQL queries, not Spark SQL, but T-SQL. So whenever I want to run T-SQL queries, again, against Lakehouse, I can only read data. Eventually, I can create programmatic objects like views or procedures, but in general, it is for reading. I can write queries, so I just can switch to Query tab at the bottom and write my SQL query. I have several queries to run later on. Second object is Warehouse. If I go to Warehouse, the Warehouse view is basically, I would say, the same as the SQL Analytics endpoint view of Lakehouse. So again, you see tables, you see programmatic objects, schemas, etc., and then you have your queries, which can be built in one of 2 ways: programmatically using T-SQL, or using visual way, which is very similar to Power Query. But I will not build visual queries because this session is for SQL developers. And then let me stop here with showing the objects. I will switch to KQL database later on and show you this database. But right now, my demos will be related to warehouses and lakehouses. So let's switch to my control plane notebook. This will allow me to switch between different pieces of T-SQL and SQL code, not just SQL, Python code as well. But let's start with the lakehouse. So typical way to work with lakehouse is this. You use some method to load the data into the lakehouse. What methods you have to load the data? Maybe let me quickly go back to the lakehouse. Sorry, just one moment to spend in the lakehouse, because this is absolutely required. So if you can see, if you wonder how I loaded all this data to my lakehouse, it was pretty much straightforward. I just used the simplest way existing. It is uploading from my PC. So when I have my files on my computer, I can upload files or folders, create new subfolders. Basically, it's all under right-click in Files section here. But when it comes to creating tables, you have several ways as well. The simplest way, if you have Parquet or CSV file, is right-click on your file in the Files section and use Load to Tables option. That way you can create tables that will be visible in Tables section. But you also have other mechanisms for loading data from external and internal data sources, and specifically those two are super useful because they can be automated and they can be powerful in terms of how you can transform data. So establishing some knowledge on data pipelines and data flows generation too will allow you to effectively load your data into lakehouses, warehouses, KQL databases, whatever you have. Now, having said that, let me switch back to my first demo, and this will be about how you normally work with lakehouse. After you load the data to the lakehouse, the typical way that you will be using as a SQL developer will be this. You will start a new notebook. It is as simple as clicking open notebook, new notebook when you are in the lakehouse. So that's how I created this notebook. And then you add two things. One, code, which may be a mix of languages. By default, you are using the language that is specified here at the top bar of the notebook. And by default for me, it is Python, actually PySpark. So this code is PySpark. But you can switch between different languages, and I will show you that in a second. SQL will be my friend in a second in this demo. But also, you can, if you don't know how to write Python, you can easily generate code because you are attached to your lakehouse. So you can, for example, navigate to your Parquet file, upload it to the lakehouse, and just simply drag and drop the code, the file, to the notebook. And that will create a simple code that loads the data from your files to the object called data frame, and it is distributed tabular object that serves Spark for data processing. So when you have data in a data frame, the next step as a SQL developer for you may be to load this data from a data frame to something called temporary view, which is, you probably feel what it is. It creates a temporary tabular view on the data that is stored within your data frame. So now you can operate with SQL, purely with SQL, by switching to SQL language, Spark SQL language, using this magical command. %% SQL as a first line in your shell code, and you can operate with SQL. So you can see I join two temporary views to have my analytics done in this simple code. As simple as that. So the pattern here, load the data from files into data frames, create temporary objects or tables if you prefer, or even you don't have to create those tables, but then you will probably operate with PySpark rather than SQL. So if you want to operate with SQL, the easiest way is to create those temporary views and then operate over those temporary views. Please note that the second part beyond code is the markdown. So I can document my code in notebooks using markdown. So this part was generated using some some magic, right? Because Markdown is not just text, it's also a piece of formatting. It can contain images, etc. But in general, you can document your code and present some guidance on how this code works and what it shows up. It may be saved or exported for other developers and serve as a documentation as well. So also you can go back from SQL to Spark data frame, because Spark offers you this Spark SQL method, and you can load the data from your select statement straight to the data frame and operate in Python. So you have both way going between languages if required. And if you want to write data to files, Python will serve you well, because it can you can decide which format you will use and which option in terms of overwriting, etc. So when you save to files section of the lakehouse, you typically use PySpark. But also you can use SQL when you have your data in temporary views or in tables, sitting in the tables section of lakehouse. You can use create table as select statement, just as I'm using here, and simply create another SQL object. So I create a table with aggregated data by running a SQL command over other tables. So this tripag table appears here, right? So I created this table using SQL, a SQL language, and create table as select is one of the patterns that you will be using not just in lakehouses, but also in warehouses in Fabric. Please note that for data transformation, especially when it comes to taking care about data quality, you may find some functions that do not exist in T-SQL but are present in Spark SQL, and some functions that are served by Python language, more useful than things that you might know from SQL Server. So for example, to get rid of duplicates from your data frame, and then of course from SQL objects in your lakehouse, you just use drop duplicates function, and that's it. If you want to get rid of empty values like nulls, right, you will just use this NA drop function, and this will immediately locate all the unknown values in all columns in your data frame, and it will just delete whole rows that contain those values. You may also use other functions that, for example, will fill the values, the unknown values, with some predetermined values. So you can replace unknown values with zeros or whatever falls into your business logic. So again, I wouldn't stick just to SQL, because Python is pretty powerful. It's the most powerful way to operate with data in notebooks. But again, you can switch between the language of your preference and languages that may offer some more options, like Python in this example, very smoothly in notebooks, just by using those magical commands. All right, let's switch to the second demo, which should be T-SQL over lakehouse. So I showed you the way to work with Spark notebooks. Now let's run some SQL code, T-SQL code this time. So first observe that here I have queries that run over metadata tables, system views. So just like in SQL Server or other Microsoft databases, Lakehouse and Warehouse come with the same layer of pretty much the same layer of metadata. So you have your sys tables, sys columns, etc. You can run queries over those views to get metadata, which is good. You have ANSI compatible information schema views available as well, so you don't have to rewrite queries that based on metadata. Keep in mind that in terms of dynamic management views, the set of dynamic management views for use with warehouses and analytics endpoints will be limited. I would say about 30 of them will be operational. The rest will just say it is not supported, but again, you can try them on your own. Now, if you want to run analytical queries, you just run your T-SQL, but for that, you need to create tables in your lakehouse. So again, with Notebook, I could query data that was sitting in files section. With T-SQL, you only have access to tables, especially tables that are created using Delta Lake format. But then again, you can also, in terms of writing or creating some objects, you can create views, functions, and procedures, but you cannot write any data. So inserts, updates, or deletes are not supported in T-SQL versus Lakehouse. I hope that you find this informational. Now, let's move to the warehouse. In warehouse, you typically operate fully using T-SQL. So not Spark SQL, not notebooks, but T-SQL. So first of all, you can create tables from the scratch and then fill those tables with data. Here I'm creating just a simple dimension table using create table statement. Okay. Temp tables. The use of temp tables is limited, and I will refer to that in a second. But this is a good question. So I created a simple table. Please note that table definition in case of warehouse is different than you might know from table definitions in dedicated SQL pools in Azure Synapse, because there is no information on distribution. So distribution is actually being done behind the scenes for you. You don't have to worry about any kind of distributions. Also, please note that you may create things like primary or foreign keys, but those constraints are not enforced. They are for informational purposes only, to show up in data models, but it will not enforce any data consistency across your database.
James has a question. Are temp tables supported with install procedures on SQL?
I'll get to that in my third script in this demo.
Great.
Thanks. So after I create a table from the scratch, empty table, the easiest way with T-SQL is to use well-known copy into statements. So you just select which files you want to load to your table. You specify the format and maybe some additional options. Like in this case, I'm telling that the first row of the CSV file is a header row, and then I load this data into my table, and I should have 6 rows in my table, because this is the number of rows that exist in the CSV file. As simple as that. But again, this is fully transactional database, so I can also write data using insert statements and also update data and delete data. And as you can see, there is this 7th row that I've just inserted using simple insert. Keep in mind, merge statement is not yet there. This is one of the limitations that we currently have in T-SQL Surface in warehouses, but I will refer to that in a second. So now, let me go and show you the way you can use multiple data items using a single query. So here I am jumping and querying demo lakehouse. Keep in mind, I'm sitting in the warehouse right now, but I'm querying the lakehouse that sits in the same workspace, and I can just see the data that sits in a table that I created in a lakehouse, in another object, or other team created in a lakehouse. And then I can join the data that I have in my newly created table in my warehouse with the data that sits in the lakehouse. Please note this 3-part name convention. So just like in SQL Server, you could query multiple databases, it is possible here between lakehouses and warehouses. So I just create an analytical query that runs and queries 2 tables sitting in 2 different data items, 2 databases. Now, you also will operate with create table as select statement for transformation purposes. So whenever I want to create a table with some transformations, it is easy to use select statement with some ways of transformation or adding additional columns, like for example generating numbers or getting rid of null values, and then I write back the result of the select as a new table. In this case, my fact table. So let me create a fact table using create table as select. And then Just because it is a set of normal standard SQL tables, you can operate with grant, revoke, and deny statements to operate and grant permissions to read data from those tables to analysts and people who will read data using SQL. Of course, you can implement some more sophisticated security mechanisms like data masking or row-level security. I will not jump into those sections, but just keep in mind this is possible. And here I have a query that runs internally on objects created within my workspace. Now, the question was about temporary tables, so I will just take this link and paste it in a chat window. Unfortunately, you will notice that there are some limitations when it comes to operating with T-SQL. Temp tables are among those limitations. Sorry about that. So the typical pattern is this. If I was about to create and serve data through warehouse, I would consider going for bronze and silver layer of medallion, which is classic implementation, with lake houses, and then do all my transformations using more powerful notebooks and Spark SQL with Python, and prepare data in ready to use to serve shape for my warehouse tables, just to load this data using any of the methods, either data flows or pipelines or copy statements in stored procedures, and that would be it. So again, you will see that there will be some differences between the way you used to work in SQL Server, for example, and in here in Fabric. And I guess, don't get me wrong, but again, this is a distributed system, so you will face those limitations because the engine is new. It is nothing that you are familiar with. The engine is completely new, drawn from maybe not from the scratch, because we are using some existing implementations like Polaris runtime. But again, this is new and distributed, so it will take some time to get to the full scope of T-SQL in the future. I hope you still get the idea. You don't have to worry about the lack of temp tables, because you still have plenty of options to get your data shaped before you load data into the serving layer of your data marts stored as tables in data warehouses. Now, for KQL, you will see that you can actually run queries using SQL, but I would be tempted to say that you will quickly discover that KQL is the most powerful way to work with the data that sits in KQL query database. So here I have my stocks daily table that is stored within my KQL database. Before I jump into the next demo, let me switch to the KQL database for a second. So this data was actually created in a very simple way. You can create data using sample data that is presented to you by Microsoft. And this stock daily is actually one of those tables that Microsoft presents as a sample data. But for this table, I specified that it will be stored in one lake folder. You have to change this option if you want to make this table available for shortcutting in lakehouses. I will show you shortcutting in a second. But then, once I have my table with data in KQL database, I will operate typically with KQL. The KQL is very straightforward. You start with the name of your table, maybe with some variables, and then specify next steps of your queries. Like, for example, here I'm taking just a random 100 rows from my table. I run this query and it displays 100 rows. In the next query, you notice similarity to SQL. I specify my tables, but then I'm saying, hey, just show me those records, those rows in the table that have ticker column equals to Microsoft, and then show me just two columns, date and close. So the result is just like select date close from stocks daily where ticker equals Microsoft if I was writing T-SQL. Now, here is a T-SQL query on the other hand. So I can run T-SQL because this database also has the T-SQL endpoint built in, but it can only accept some limited subset of T-SQL queries. If you want to move smoothly between T-SQL and KQL, you can use explain command over your queries written in T-SQL to get the corresponding KQL query. And then you can learn KQL by writing your SQL and explaining it in this way, right? And then I can run the same query translated to KQL. Now, why you should consider KQL? Because it has lots of features built in. By default, KQL database is not only optimized for analytics in terms of it is stored as a columnar database. It is also stored in a way that it has textual columns heavily indexed for search operations and text processing operations. You will see that there is a bunch of functions in KQL that is far beyond what you see in T-SQL when it comes to specifically observational analytics. So whenever you have to deal with logs and telemetry, data that in which rows may be somehow correlated. For example, in security logs, you will be looking for a series of events rather than just a single event. And that leads to some examples here. So here I'm using scan function, which is basically for building a kind of a process mining queries in KQL. It takes all the rows classified as Microsoft in my the stocks table, and it searches for the longest growing period in terms of price, stock price. So it will tell me for Microsoft in which period day by day, I observed growing prices. Okay, a single row of data. Of course, you can build it in T-SQL, but it is far from what I would call a process mining. While here, I'm just building steps that determine my process, and I run this scan function, which returns this outcome. From this date to that date, the price was growing for consequent 14 days from this price to that price. So again, that is something that is really powerful use case for KQL. There are by far more, like things like regular expressions or quick searches in textual data. KQL has many applications beyond analytics. It's also for some scenarios related to security. All the logs and security analytics in Azure is based on KQL. Log analytics is based on KQL. Our PM teams have their telemetry queried by KQL. So whenever you open support tickets, there is a good chance that somebody will run some KQL queries ready to use to locate your problem and find the solution. Okay. Getting back to my demos, because I still have a lot to show and not that much time. So shortcuts. I will not show you how to create a shortcut end to end. I will just, oops, it happens. Instead of that, I will just show you where you can create shortcuts. So typically you will create shortcuts in lakehouses, both in files and in tables sections. So keep in mind, you can create shortcuts in tables and files. And to create a shortcut, you simply click on the files or table section, or maybe on some subfolder, and choose option new shortcut. And then you have several options to select. Microsoft OneLake will allow you to create a shortcut to tables that sit in other data items, not only within your workspace that you operate right now in. So you see the whole tenant in terms of all the data items that I have access to. I can select from warehouses, lakehouses, and other objects that sit in different locations, different workspaces. and then I specify tables, and it will create a shortcut. Everything that has this little shortcut icon here on a table is a shortcut. So you can see that I have 1, 2, 3, 4, 5, 6 shortcuts in my lakehouse right now. And also I have a shortcut created here to an external Azure Data Lake storage that I've been using with Azure previously. And again, why shortcuts? Because they do not copy data. They just point to the data that exists somewhere else, but you can use the data as it exists in your data item, in Lakehouse in this case. And what can you do once you have this? Once you have this those shortcuts created. So first of all, I can use T-SQL. If I created a table, a shortcut to a table in tables section of my Lakehouse, I can go and select using just the name of the table. So here I created a shortcut called trip large, which points to another Lakehouse in another workspace, and this table contains 1.5 billion rows. So imagine how long it would take to copy this data, and how much space in my OneLake storage it would take. I would pay additional money for that. So it will allow you not only to avoid silos of data, keeping copies of data in many places, but also to save money. And I can effectively query this data using T-SQL. Here I have a shortcut created to stocks daily table sitting in my KQL database. So again, querying data like it was stored in my Lakehouse. Nothing beyond that. Also, I can create shortcuts to semantic models. Now that is a bit of additional actions to take, but let me show you first that it is possible. Again, if you create a shortcut to semantic model, you only can use Spark SQL, not T-SQL. So Notebook is your friend in this case. But hey, this query, after I switch to SQL language in Notebook, I can run a query over my tables that come from semantic model. Time and financials are coming from semantic model. How this works? If you want to specify that your semantic model will be stored in OneLake, you have to go to your semantic model settings and select this option, OneLake integration. It will also ask you to enable large semantic model storage format, but then you should be good to go, except that you will need also to run this simple XMLA query. Sorry for that. I had to jump and show you how hard it is to create the shortcut to semantic model, but it's possible. It is not the natural way to work with semantic models, but if you for some reason, if you really want to work with notebooks over semantic models using shortcuts, so your tables from semantic models are visible in tables section of your Lakehouse, this is the way to go. Right. By the way, once we are here in SQL Server Management Studio, let me quickly go and show you something. For warehouses and SQL Analytics endpoints, you will see that there is a SQL connection string available in options, and you can copy this connection string for use with external tools. So I can connect to a database, paste the connection string, connect using Microsoft Entra authentication, and guess what? After I select my authentication login and provide some passwords, I will successfully connect to a server, some SQL server that stores all databases, lakehouses and warehouses that sit in my workspace. So I can see my demo lakehouse and demo warehouse immediately with all the tables. I can run queries from this environment, etc. I will not go into this right now. I'm running out of time, and I still have some questions to cover. So let me quickly jump to some extras that I wanted to show you. Semantic link is one of those things, and also a native connector for Power BI that exists in Spark. So semantic link. you need to run some installation commands in your notebook, and then you can operate with semantic link library specifically in Python. And if you want to run SQL, Spark SQL queries over your semantic models, you don't have to create shortcuts. Instead, you can set up your Power BI Spark connector, and then notice here I am using this naming convention, PBI dot the name of my semantic model dot name of the table, to select data effectively from my semantic model tables. That easy. So this line here, it actually causes that I can run queries like that right after in my notebook. But once I enable semantic link, I can do more stuff. For example, with a few lines of Python code, Python, not SQL, I can verify metadata of my semantic models. Pay attention, we are not the best in renaming our naming conventions, still data set appearing here. You can even draw the relationship diagram using methods that are served by semantic link, and you can run DMX queries that will grab the whole details of your metadata behind tables, including data types, dictionary sizes, etc. So this is the great way to document and even refresh your semantic models, because it is also possible to refresh semantic models using this library. And one more thing to show you, maybe a bit more fancy, but still SQL, and more SQL. If for some reason you want to play with something that will be more lightweight than Spark that is present in Fabric, you can install lightweight SQL engines in Spark. For example, here I'm installing DuckDB just from external library, and then I use a select statement inside of this engine, of this little engine that probably will use just a subset of my capacity power for querying files and creating tables. So again, lots of powerful options. I will not go into details of that. But before I take your questions, to wrap it up from T-SQL Rex, what I would invest my time if I was a SQL developer jumping into Fabric: Spark SQL and Python to effectively operate over lakehouses and other objects, because again, you can create shortcuts, effectively connect data from different data items. Data factory objects, items like pipelines and data flows, because they will allow you to grab data and transform data and load it into your lakehouses and warehouses and KQL databases in a simpler way. Medallion architectures, so bronze, silver, gold layer, how to implement this. We have a documentation and even a training on that. I will show you some links later on. And direct lake mode, which I didn't cover here, but it is super strong mechanism to query data sitting in lakehouses and warehouses from your semantic models. And of course, development using generative AI. If you have this chance and you have F64 capacity, you should establish this. Enable Copilot by just clicking Copilot in your notebooks, for example, right now in notebooks, and you can then put your prompts and generate some code using generative AI. So for example, here I'm asking, hey, can you just take the data from the payment hotel reviews folder, CSV files, and load it into temporary view? So everything that I showed you in my first demo today can be generated using generative AI. You don't have to learn SQL to start working with both Python and SQL. Up to you. I would learn still both of those languages, but generative AI is a great help, especially if you need to quickly start with those languages. And then additional stuff. If you want to really fully cover Fabric, then absolutely you cannot omit the Power BI part of it. So DAX and semantic models semantic link as an extension, and KQL. Brian will echo me. Learn KQL because it has lots of applications, and
Indeed.
it is great fun to program in this language.
Yeah.
So, with that, this set of resources is very much related to what I showed you today. I will serve this deck as well as demos in my GitHub repository. The link to this GitHub repository is here. So github.com/pawelpo. That's my GitHub. You can then find presentations repository, and yeah. So this is my presentation. Should I paste the link into the chat? Probably yes, but let me just maybe write it down.
And then perhaps we still have Gupta-Ashi an answer to the questions.
Yeah, let's switch to questions. Absolutely.
This was the questions about the capacity and the usage of the one-leg storage. Yeah.
So first of all, what I would suggest is typically if you have any challenges related to things like Fabric capacities. Look for documentation on specific things. So Fabric capacities should be not in the blog. This is learning. Scalar capacity. Pause and resume capacity. I am pretty sure that the capacities have their documentation, which sorry, I don't have capacities and SKUs. Yeah, so here you can see the amount of cores. I'm not sure if this contains any other stuff. Yeah, so probably we don't have it covered in documentation when it comes to storage, right? Because the question was about storage.
Yeah, and how can you see how much storage you're using in the one leg?
Okay, I'm not that much into administration stuff, but let me try to find it. If you go to capacity settings, in my case, I only have the trial capacities. Let's see what users report shows up. I am pretty sure I have my capacity metrics. Well, I don't have it. Oh, probably this is because there is a new version. I think that storage information is here as well.
Yes.
So I will take a look at capacity metrics. You have to install the external applications. The external application called Microsoft Public Capacity Metrics, attach it to specific workspace or specific capacity, and then you will be able to look into details of capacity usage. I think including storage as well.
Yes, indeed, okay? Indeed. In the Fabric Capacity Metrics report, it's actually an app. There is a pane.
In terms of storage and the lack of it in documentation. Let me just go and check one more resource. Public pricing. No, I don't see the options of storage here as well.
No. But
look. Let me do the following. I will drop you an email to me in the chat, and just please remind me with this question. I will probably have to have a look around and just let's just take this question about the amount of storage assigned to capacities offline. Okay, I can't memorize it. I don't remember. Okay. So just drop me an email on that. And I will try to respond with some meaningful answer. If not from documentation, then at least with some values, right? But for sure there are some limits on that, absolutely. But then you typically pay for the amount of storage. So I am not that sure if there are limits. I mean, limits are put on the size of models, like semantic models, but whether there are limits on specific capacities in terms of the amount of storage, I don't know. I have to check. Sorry.
Yeah, there are no limits for the amount of storage in Fabric, no matter what capacity you have.
MVPs know better.
Yeah. And in the Fabric capacity metrics, you have a small. It is not very obvious, but in the top, just underneath the headline Fabric capacity metrics, you have a link to the OneLake, and in that you can actually see what your size of your current OneLake in your entire tenant is, and you can see two measures. You can see what is the current storage and what is actually the built storage, because you are not built for the entire storage. You are only built for the unique amount of data. If you have a duplicate data set and Microsoft can figure out, oh, this is duplicate, you are only paying for one copy of that data.
You don't buy any additional storage.
No. The storage is just built per terabyte.
Storage is built, yeah, just here you can see the pricing of storage. So storage is basically, the price of storage has several factors that impact it, but it's not like you buy it separately. You are just built whenever you use the storage, rather than buy it from some store or whatever. So yes, it's not that you provision any additional storage. It just exists there.
Yes.
Any other questions?
I don't think we have skipped any other questions actually. It's just James and I chatting about some guy blogging about real-time analytics, and yeah. So
if Fabric is something new for you, then I would also use those resources. I mean, try Fabric is a natural way to start working with this environment, but also I would recommend those resources. There are free modules for Learn. We expand those modules practically every month, so you can even learn things on how to implement medallion model, recently added training. I know that we also launched the beta of DP600 exam, so if you're interested in certification on Fabric, it should be there very soon.
Today, actually.
Yeah, and there are some end-to-end scenario tutorials. There used to be just 4 of them, but right now I think there are plenty more. So you can learn not just scenarios related to SQL, but also to, for example, implementations of data factory items, pipelines, data flows, etc. So make sure you go there, because those are step-by-step instructions just to follow, easy to use, and absolutely. So everything that I used today was based on the TLC trip record data. I created some CSV files with mappings for dimensions, but really you can just go to this little page. I will paste the link into the chat window and download some, even some more meaningful amount of data, like billions of rows. That will probably take several files to download, not just a single month. But even a single month contains typically a bunch of millions of rows to analyze, so you can play with that. And it's served in Parquet format, as you can see, so it can be easily consumed in Fabric and in other platforms as well. Yeah, and also please keep in mind that you have different options to purchase Fabric if you're interested, along with the reservations that are available in terms of provisioning Fabric capacities in Azure. So those options, you have to go to Fabric pricing website to find more details, actually. So yeah, any other questions?
No, I think the questions has been answered, all of them.
So just in case, make sure you play with Fabric, download this presentation with links that I shared in this presentation, I hope you will you enjoyed this session and that you will have some fun with Fabric as well. The product is still very young, so make sure that whenever you find some gaps or you have something that you desperately want to see in the product, let us know. On the previous slide, there is a public website that you can use for sharing your ideas with us. So the product team is having a look at that constantly, and we try to implement things that will meet the requirements of most of our users.
Yes. So
thank you.
Thank you, Pawel. Thank you for the presentation. And I hope all the attendees learned a lot. We had just around 50 attendees. So
well, apologies for over timing.
That's fine. That's fine.
I was actually guessing that may happen.
Yeah, and that's fine. And stick around in the LinkedIn group for the video if you need to rewatch it or share it with your friends. It will be up hopefully next week somewhere. And then just a comment from James Reeves: please change the shortcut icon. Because it is only a small change with the 2-chained link or something at the top left corner. But I totally agree. So enjoy your evening. Thank you, Pawel.
There's still lots of things to cover. Yeah.
Oh, to Peter, the LinkedIn group. I'll just let me find that LinkedIn group. The link. Just hang tight a few seconds, and I'll find the LinkedIn group link for you. I got it right here. And I just put it in the chat to you, Peter. There you go. Just join that group and you will get a notification with a link to YouTube to see the video again. So,
all right.
Yeah, without further ado, thank you again, Pawel, for the session.
The rest of your day.
Thank you all for coming and hope to see you next time.
Cheers.
Thank you. Bye.